Hello everyone. Today we will discuss one question from linear algebra that was asked in CSIR NET in December 2013. So let's start our discussion. Question. Let the collection V1, V2, etc. Vn be a linearly independent subset of a vector space V with dimension n where n greater than or equal to 4. Set Wij equal to Vi minus Vj. Let W equal to span of the set Wij where 1 less than or equal to I, j less than or equal to n. Then we are given four options. We have to find the right options from the following options. Let's consider the first option. The set Wij where 1 less than or equal to I less than j less than or equal to n spans W. That is, when we take any element from W, we can write that element as the linear combination of the elements from the given set. Okay, that is, if we take one element from W, we can write that element as the linear combination of the elements of the given set in option 1. Here we have one condition, I is always less than j. Wij were 1 less than or equal to I less than j less than or equal to n. But in the case of W, we don't have that type of restriction for I and j. But here I is always less than j. Please keep that in mind. We have to check span of this set. Span of this set means the set Wij 1 less than or equal to I less than j less than or equal to n is W or not. We take one element from the set that is given in the first option, Wij 1 less than or equal to I less than j less than or equal to n. So we take one Wij from that set. Wij is equal to Vi minus Vj. We took the element from this set, so I is always less than j. Then consider Wji. So we said I is less than j, that is j is greater than I. So here j is greater than I. It's clear that this Wji is not in the given set, because here the first index is always less than j. Here j is greater than I. So this Wji is not in the given set. But this element belongs to W. So Wji equal to Vj minus Vi. This equal to, take minus from this equation. So minus Vi minus Vj, this equal to Vi minus Vj is what? Wij. So we get Wji is equal to minus Wij. That is, Wji is a scalar multiple of Wij. Here j is greater than I. So this element, this Wji belongs to the span of the given set. Span of the given set. This Wji belongs to span of this set. So we can say that the set Wij such that 1 less than or equal to I less than j less than or equal to n spans W. That is, option 1 is correct. Next, we consider the second option. The set is the collection Wij where 1 less than or equal to I less than j less than or equal to n. We have to find is a linearly independent subset of W or not. Consider the case n equal to 2. So our set becomes Wij 1 less than or equal to I less than j less than or equal to 2. When n equal to 2, the set contains only one element, that is W12, because I less than j, here 1 less than 2. So this set contains, when n equal to 2, this set contains only one element, that is W12. W is, when n equal to 2, W is equal to span of W12, W21, W11, W22. So the set contains only one element, that is W12. Therefore, is linearly independent. Next we take n equal to 3. Then the given set contains the elements W12, W13, W23. Here 1 is less than 2, 1 is less than 3, 2 is less than 3. W12 means what? V1 minus V2. W13 is equal to V1 minus V3. W23 is equal to V2 minus V3. Then take W12 minus W13 plus W23. This equal to V1 minus V2. Just substitute the values of W12 in the given equation. So we get V1 minus V2 minus V1 minus V3 plus V2 minus V3. When we add this, we get 0. That is the W12. Here we take one linear combination of three these three elements. So the coefficient of W12 is 1, W13 is minus 1, W23 is 1. When we take one linear combination of this element, we get 0. That is W12, W13, W23 is not linearly independent set. Okay, the set W12, W13, W23 is not a linearly independent set. That is option 2 is incorrect. The given set is not a linearly independent subset of W. Hope you get the idea. Next, we have to consider the third option. The set Wij where 1 less than or equal to I less than or equal to n minus 1 and j equal to n plus 1 spans W. Here, the first index I have one restriction 1 less than or equal to I less than or equal to n minus 1 and the second index j is equal to n plus 1. We have to check the given set spans W or not. That is, if we take any one element from the given set W, we can rate that element as the linear combination of the elements from this set. If we take any one element from this set given in the third option, the element is of the form Wi plus 1 because see here j is not equal to n plus 1, it is I plus 1. The set is Wij 1 less than or equal to I less than or equal to n minus 1 and j equal to I plus 1 not n plus 1. I'm really sorry for the confusion. It is j is equal to I plus 1. So if we take any element from this set that is given in the third option, it is of the form Wi plus 1. Okay. Wi plus 1 is equal to Vi minus Vi plus 1. Okay. We have to check this set spans W or not. That is, if we take any element from W, that is the linear combination of, we can write that element as the linear combination of the elements from the given set in third option. So we take one element Wij from W. That is equal to Vi minus Vj and we add and subtract Vi plus 1 and Vi plus 2 and etc. up to Vj minus 1. Okay. Vi minus Vi plus 1 plus Vi plus 1 minus Vi plus 2 plus etc. Vj minus 1 minus Vj. This implies Wij is equal to Vi minus Vi plus 1 is Wii plus 1 and Vi plus 1 minus Vi plus 2 is Wi plus 1 I plus 2 plus etc. Vj minus 1 minus Vj is Wj minus 1 j. Okay. That is, we can write this Wij as the linear combination of the elements from this set. This Wii plus 1, Wi plus 1, I plus 2, Wj minus 1j, all these elements belongs to this set. So we can write any element from W as a linear combination of the elements from the given set in the third option. That is, this set spans W. So we can say option 3 is correct. Next we consider the fourth option. Dimension of W is equal to n. We need to check whether dimension of V is equal to n or not. Consider the elements W12, W13, etc. W1n. These elements are linearly independent because W12 is what? V1 minus V2. W13 is V1 minus V3 and etc. W1n is V1 minus Vn. We know that V1, V2, etc. Vn are linearly independent. Therefore, these elements are linearly independent. And note that here we have n minus 1 elements. Don't think that it is n. W12, W13, etc. W1n, 2, 3, etc. n. Here the variation occurs only in the second index 2 to n. So only total n minus 1 elements. Don't think that it is n. Okay. We take one element Wij from W. We can write it as W1j minus W1i. How we can write like this? How we can write Wij like this? We can expand this. W1j is equal to V1 minus Vj minus W1i is equal to V1 minus Vi and is equal to V1 minus Vj, open the bracket, then we get minus V1 plus Vi, cancel V1, so we get Vi minus Vj. Vi minus Vj is equal to Wij. So we can write Wij is equal to W1j minus W1i. That is, we can write any element of W as the linear combination of element of these elements. We take one element Wij from W and now we write this element as the linear combination of these elements. Okay. These elements are linearly independent and these elements spans W. So we can say that the collection W12, W13, etc. W1n is a basis of W. That is, the dimension of W is n minus 1. Therefore, the option 4 is incorrect. Answers are option 1 and 3. Hope that was clear to you. If you like the video, please do like, subscribe and share. Thank you.